Yeah, it's sharing now.
Now it's sharing.
Yeah.
Alright. So I just decided we just repeat again question 2 so that we clarify those things again. And remember the question here, we want to perform a measurement of A, where A is measured first and then B immediately afterwards. So we find the probability of obtaining a value of root of 2 for A and a value of -1 for B, where you are starting measuring A, then B. Now we measure B, then A, immediately afterwards, finding the probability of obtaining a value of -1 for B and a value of root of 2 for A. So the values are still the same, only that when you're measuring, we are starting there. So that time, when we were explaining, we said you are given your vector, the vector that were given in our question paper, this one, which is 513 psi, 513. And then we said we normalize it. By normalizing it, we want that vector to be a unit what? Vector.
Mm.
So here we are normalizing. So whenever you see this, it's normalization. This just means the square root of that vector. So this is just the square root of that x coordinate squared plus the y coordinate squared plus the z coordinate squared. So in other words, what is inside the bracket? This gives us 35. So 5 squared plus 1 squared, which is 26. 26 plus 3 squared, which is 9. So we have the magnitude. So that one giving us the magnitude of what is inside. Then squaring, if you square, that will be the unit vector, which is 1 over the magnitude. That's how we got the 1 over root of 35. So this is our normalized vector. So the n there, so psi n, it's referring to is the normalized vector. Why is it normalized? If you multiply this, everything inside, you get a 1. Get a 1. That's what it means. It has been normalized. So the n, it's a normalized vector now. All right. Then we're given the values of A, B. These ones are given from the question. A, that one. B is also given from the question, as you can see in the question paper. B, that is our B. And then what we are finding for B, the eigenvalues of B. How to find the eigenvalues of B. So first, we have 1, 0, 0. And we also have 0, 0, 1, 1, 0, 1, 1. And we also have, and remember this one, it's being multiplied by 1 over root of 2. Why is it being multiplied by 1 over root of 2? We are saying this is a unit vector, 0, 1, 1. If you multiply it by root of 2, we get a unit vector of 1. Why are we getting a unit vector of 1? Because we are saying 0 squared plus 1 squared plus 1 squared. So in other words, we are saying 1 over root of 2 multiplied by the square root of 0 squared plus 1 squared, which means it just give you 2. So 1 over root of 2 multiplied by root of 2, this is same as 1. And then you do the same, we get also a 1 that side. And then here for B. So we are having two where we at first we are starting A, we measure A, then B, then we also measure B, then A. So we are given. So the value of A, root of 2, then the value of B is -1. So here we want the value of B where it's -1, value of B where it's -1. So 0, 1, and -1, which means we have just, when you put B as -1, you're just multiplying that vector, any of the vector inside, by a -1. Right. Take the negative out, still the same. So which means when you multiply by -1, B -1, it's still the same, which means equals to, when you want to check if the unit vector is equals to 1, it's root of. Then you multiply it by 0 squared, 1 squared, plus a negative. Remember, it's a -1, which is being squared. It's a -1, which is being squared. So at the end, we get the root of 2, then they cancel out. It's just equals to 1. So that one is also a unit vector. So for
I
A,
don't
yes.
I don't think I understood that part where
Which
you're
part?
agree the 1/2 is because when you there is the unit vector when
Yeah, take the vector.
when you normalize it, it gives you the square root of 2, right?
Mm, mm.
So that one is 1/2 square root is because it's the one that is gonna cancel the square root of 2, the square root of 2, and it gives you 1, right?
Yes. Mm.
And then now the which where is this uh, the 1 squared that you're multiplying with? It's 1/2 multiplied by, where is that 1 squared plus -1 squared coming from? Because I see 0, 1, and is it these ones, the 0, 1, and -1?
It's the -1 you are talking.
Oh, it's fine, you can continue. I wanted to understand that one.
For A, eigenvalue root of 2 is eigenvector. So which means for our A, this is our A, 0, 2, 0, 0, 0, 1, 1, 0, 1, 1. And then we have our eigenvectors, 0, 1, 1, and 1 root of 2 as our eigenvectors for A. All of these, they give us a unit vector which is equals to for A. Right. And then after you have been given those eigenvectors for A, so the eigenspace for A equals to root of 2 is the same as the eigenspace for B equals to 1. For B equals to 1. But in our question here, our B value, we were told that the value of B has to be equals to -1. As you can see, for B equals to -1, and for B equals to negative. Don't want a B or 1. So we measure A, then B. So first we are measuring A, then B. So one, the probability from the question, it says, what is the probability? We are supposed to find the probability of obtaining a value of -1 for B and a value of -2 for A. So yeah, but how are you measuring? I'm measuring A is measured first, then B. So the probability of obtaining a value of root of 2 for A and a value of -1 for B. So that's what we want to find. So we want P probability of A equals to root of 2. Then immediately B has to be negative. So that's how you write. Probability of A equals to root of 2. Then B immediately is equals to negative. So after measuring A root of 2, the state A root of 2, the state collapses into the space which has been spanned by those eigenvectors. As you can see, the eigenvectors for A. Right. So, but this whole space belongs to B equals to 1. Like I indicated, this was equivalent to B equals to 1. Not, this space is not for B equals to negative 1. It's for B equals to 1. So therefore, what do we do? For B equals to negative 1, A equals to root of 2 is equals to 0. Hence, the probability of A root of 2, then B equals to negative 1, which is also equals to 0. So
So
which means probability is 0. Why? Because this space which we are having is for B equals to 1, not for B equals to negative 1. So finding the probability that we are having B negative 1 and B and A is equals to root of 2. Since we don't have B negative 1, we have only the space which spanned it belongs to B. The B value has to be 1. So if you don't have anything, the probability, we are saying it's 0 because we don't have any space which has been spanned which belongs to B negative.
mm,
Yeah.
so you normalize them first,
Yes,
and
we normalized it. Yeah.
so that you are going to get, and then you answer the question, the
The
probability
probabilities, yeah.
or not.
Then for B, you measure B first, then A. You measure B first, then A. Now it's the reverse.
What?
So we want the probability where B is negative 1, then A must be root of 2 immediately. So the eigenvector for B equals to negative 1 is this one where we changed the negative, we introduced this negative, which we're asking about. So that is
Mm,
the eigenvector of B equals to negative. So we want to find the probability of getting a B which is equals to negative 1. What do? You normalize. We
mm-hmm.
have the normalized vector, and then we dot the one for B negative 1. So this is a vector for B negative 1, and then dot product with the one that we calculated, the normalized vector that were given from the beginning of psi, the normalized psi vector. So now we know the vector of B, which has been normalized. So this B, remember, it's a normalized vector, the eigenvector, sorry, or which corresponds to B of a negative. My network is freezing this.
Mm, it's making a sound.
Let's see how it goes. All right, so this is the dot product. So this is our vector, which eigenvector, which corresponds to B negative 1. and this is the normalized vector for psi, and then this dot, you are dotting the what? The two vectors. So the first component multiplied by the second component plus, so it's a dot. That's why our answer is going to be a scalar, a number. Why? Because we are taking the first component. If you add the first one over root of 2 will give you just 0. So
So
if you want to simplify, yes.
can we please go back to number A? I want to understand something.
Okay.
Uh, Number A. Uh, did we? Where did we start with number A?
Where we had the vectors.
This is when we were doing A, right?
Yeah, where we are starting with A, then B.
So in A, we took the we normalized. We started by we had the in number A we have the square root of 1 over square root of 2, right?
Mm,
We found we used the what do you call them, the eigenvector 513. We normalized,
yeah,
right?
yes.
And then when we normalized them, we found the value of square root of 35.
Mm,
Then
this one. Yeah,
yes,
mm,
and then you put it beside the eigen vectors. And then we moved to number B. So in number B, where did we get this value for 0, 1, and -1 again?
these are the eigenvectors. Isn't it for B? These are the eigenvectors which were corresponding to B -1. This one. Where we said for B -1, this one. The eigenvalue which corresponds to B -1, it's 1 over root of 2, 0, 1, negative. Then the ones which was corresponding for B, there were two eigenvectors, 1, 2. But here for B, we are having 1, which is corresponding to the negative number, which is -1. Only one eigenvector, which is the one that we are using here when we are normalizing, which means dotting the product. So here it's dot product, which means you have the first vector and the second vector. Just like what we did in the beginning there, the first vector, and then you have the second vector, then you dot. So I was trying to explain to you how the dot product is going about. So they are taking this component to multiply by the first. Then you take 1 over root of 2 multiplied by 1. Then what do you get there? Get 1 over 2.
So the
Then
eigenvectors we found in B, we did we calculate them?
1, -1 over root of 2. And then you dot with the vector, which we are having that side. 1 over root of 5 multiplied by that, which means it will be 5 over root of 35.
Mm-hmm.
5 over root of 35. Then 1 over root of 35.
Mm.
Then lastly, comma,
Over square root of
3 over root of 35. 3 over root of 35. then you close your bracket. So if you dot, you are taking the first component, multiply by the first component, plus the second component, multiply by the second component. So first, which means this times this, giving you 0. Then the second component, this times that. So as you can see on the denominator, we are having 1. So it will be equals to 1 positive 1 over. So it's positive 1 over root of 70. Root of 2 times root of 35 give you root of 70. Root of 70 plus, we are adding the last term, negative root of 3 and negative root of 2. So which means there you are adding a plus negative 3 over root of 70, which means this times this, the last component, over root of 70. So we are subtracting those two. So positive and negative, these two, they change a sign. That's why we are only getting 1 minus 3. That is the minus, which is the common factor, common denominator is 70.
Mm.
Then from there, negative 2 over root of 70. Then what is this going to assist us with? We are saying the probability where b is negative 1. Where b is negative 1, it will be the square root, which means the absolute of this number. Why are we taking absolute number? Probability cannot be negative. That is point number 1. Probability cannot be what?
A negative.
Negative. Yes. Probability cannot be negative. So if probability cannot be negative, that's why we are putting the absolute. So absolute of negative 2. So which means what is inside the bracket, in other words, just minus. Minus 2, if the number is negative, becomes positive 2 over root of 70, because probability can never be negative, always a positive number. Then you square. So 4 over root of 70, you square it, it gives you a positive 70. Right. So this is the probability where b is negative 1. So after measuring b negative 1, the state collapses to this space. This is the space of b negative 1. So the eigenstate of A with the eigenvalue 0. So we want to get an eigenvalue 0, not root of 2. So remember on the question, you were told here, on the question, we want the probability of obtaining a value of A for root of 2 and B is negative 1 and B is negative 1. So we must bear that into mind when we are doing our calculations. So here we are saying after we have found our value of probability of getting a B, which is 2 over 35. Then after measuring B, we have found the probability of measuring B. Then the state collapses to, this is the eigenvalue which we're having for B. So which means this is an eigenstate of A with an eigenvalue 0, and it is not having an eigenvalue of 2. Therefore, remember we were told that A must be having, must be equals to root of 2.
Mm.
So the probability of having A root of 2 and B negative 1, it's not 0 since it's not there in our eigenspace. That's why we are saying the probability of B negative 1, then A root of 2. The one that we found for B negative 1, the probability existed. the probability existed, it was 2 over root of 35, that one which we calculated. Then, so which means these things we are saying they are coming immediately after. So the probability of A, then B must be -1. So which means then A must be root of 2. This is for question P, which is now vice versa. So first, you must have the probability of B, which we found, and the probability of A being root of 2, which we found in the earlier question, this one, the one that we found to be 0. If you still remember, we found the probability here to be 0. Then we multiply by the probability where our B is -1, which was root of 35 times 0. So this one give us 0, this one root of 35, then the final probability is 0. I will share the notes with you so that you also go through them. Where you fail to understand, just ask and I will respond. Number 3. Let's move on to number 3. Number 3, it's saying find the expression for the spherical harmonics. So those are, now we are given y in terms of spherical coordinates. You did calculus, isn't it?
Yeah.
Spherical coordinates you are given in terms of, we have cylindrical and then we have spherical coordinates. So for spherical coordinates, we are having theta in terms of r and theta. Those will be your spherical coordinates. And then here, we are supposed to, we are given the quantum numbers, ML, the magnetic quantum number, and the spin, whether it's +1 or -1. So this is what you do when you are given these spherical harmonics. Y30, which means where there is what? We have Y30 of theta and that phi is equals to root of 7 over 16 pi, whatever, and then 2 y3 plus or minus theta phi, where is equals to negative positive root of 2, root of 21, 16 pi. And then it's being multiplied by sine multiplied by 5 cos squared theta minus 1 e to the power positive negative I phi. I is a complex. Whenever you see this I, the complex, you must know that you are working in complex. I, it's root of -1. You must know that. I is always root of negative complex. You are not working in real numbers like what we are doing question number 3.1, where everything is in real, but for 2, it's a complex. All right. So this is how you approach it for question number 2. So in terms of calculus, x r sine theta cos phi. This is how you write your x. You are in 3 dimensions. In terms of x, 3D, and then y is r sine theta sine phi. And then z will be r cos theta. Therefore, what is the value of cos theta? Cos theta, it's z over r, and also you must know I think this was given in the question paper. Let me check if it was provided in the question paper, or you have to know them by heart. So they were provided. Can you see that this what we are having? It was provided in the what? In
Thank
the
God.
question paper. Yes, it was provided. So x is equal to r sine theta cos phi. Is this one? The one which I was reading here, it was provided. So cos phi. So the symbol which they are just writing like this, they are referring it to as phi. And remember, it's different with psi. This is a function. And the symbol which they used for phi, they did not use this phi. So they used their symbol like this to represent phi. So you must take note of the notation, whether it's psi or it's phi. So that is the symbol which they used instead of phi, because we are saying r x is the same, x is the same as r sine theta cos phi. It's cos phi. So instead of writing that phi like that, they wrote a phi in terms of the sign like. So you must not be confused, isn't it?
Mm.
Yes, so that is the only difference. And then, all right, so yeah, they gave you the functions, so which means you won't make mistakes. So if they want you to say what is cos theta, we are just making cos theta the subject of the formula, which is just z. Cos theta will be z over r, which means you don't have to stress. The formulas were given. So cos theta will be z over r is your z over r. Therefore, we also have the complex, the Euler identity. The Euler identity, which is sine theta e to the power positive or negative phi. Sine theta e to the power positive or negative phi is the same as x plus or minus
Oh,
I pi over r. So this is the identity that you must know. This one is not given in the question. The Euler identity.
okay.
This one is not given. Checking the question paper is not there. They expect you to know a formula. For the Euler identity, it was not given. The question paper. However, those cylindrical coordinates were given. Then we know that r in 3 dimensions. We know r in 2D is just nz, but the radius in 3D
Mm.
that's y squared plus what?
Z squared.
Yes. So what are we given? We are given that y30 in terms of theta and phi is equals to 7 square root of 7 over 16 pi, which was number 1. This is the first one. 5 cos cubed theta minus 3 cos theta. So what do you do now? You substitute where there is cos theta. Wherever you are seeing cos theta,
Oh,
you replace your cos theta with what?
with a Z over R.
Mhm. Because we are getting it from r, the cylindrical coordinates which were given in the question paper here at the end. We are getting it here, where z was r cos theta. So what is cos theta. Cos theta, it will be z over r. So here, it is your cos theta. You substitute that z over r in that function. Where you see cos theta, everywhere where there is cos theta, it's z over r. Cos theta, z over r. So if you're 7 over 16 pi, where there is cos theta, you replace. Cos theta, you replace. Any question? Right.
Mm.
Then from there, I get y30. If you simplify it, which means you expand 5z cubed over 5r cubed minus 3z over r. So you just want to make the denominator be the common denominator so that you can add and what? And subtract. So how are you going to make the same denominator? You multiply. Which means here, if I multiply by r squared, the denominator also what? R squared. I did not change the value, just a manipulation. So which means minus 5z cubed minus 3z r squared over r cubed. Now it's sorted. Then since r squared, remember from our radius in 3D, we said it's square root of x squared plus y squared plus z squared. So if I want r squared, which means I'm squaring both sides, I square this side, then the square root vanishes, then I square the left-hand side. So which means r squared, it will be the values without the square root sign. So what is it that you are going to use it? Where there's r squared, you replace r squared with what? Those values. X squared plus y squared plus z squared. So where there is this r squared here, that r squared, you replace the r squared with these values, which
Oh,
it is
XYZ.
called r squared. Yes.
Oh.
Then from there, expand and simplify. You group the like terms together, 5z squared. Then you have minus 3. This is 5z cubed, which means if you expand properly, it must give you a minus 5z squared minus 3x squared z. Then it's minus 3y squared, 3y squared z. Then also minus 3z cubed. And everything is being subtracted by 5. So 5z cubed minus 3z cubed, that's why it's a positive 2. We are subtracting this part. So 5 minus 3 give you 2. Then everything comes as it is, minus 3z x squared minus 3z y squared, everything over r cubed. Then from there, it's a matter of what is r cubed in terms of xy, in terms of x and y. So this is what is r cubed. So r itself, just the play of exponents. We are saying our r is equals to x squared plus y squared plus z squared. But everything is to the power half. Can you see? The power half. So if I multiply the left-hand side with a cube, for example, if I multiply the left with a cube, also the right, I must introduce a what? Cube. By introducing a cube exponent, we are just multiplying the exponent by 3. So this number 1 by 3, that's why it's 3 over 2, which we are having. So this is r, x squared plus y squared plus what? So this is r,
Mm.
the cube. is coming from the square root. It's r, but this r it's having its 2, this one. So the cube, then that's where it's coming from. It means 3 over 2. So we are trying to see if we can simplify it any further. But this is the end. We can't go any further. So it's ending at y30 is equals to square root of 7 over 16 pi z bracket 2z cubed minus 3x squared minus 3y squared. So the question itself was asking, for the expressions of the spherical harmonics, where y3 is 0, which is a function in terms of theta and phi. So it was just a matter of substitution. You just want your answer must be in terms of theta and phi. So, but it must be the spherical harmonics. In terms, the question is saying in terms of Cartesian what? In terms of Cartesian coordinates. So which means you are given in spherical coordinates. So you are supposed to reduce this in terms of Cartesian coordinates. Cartesian coordinates, they use x, y, and what? And z. Any question for this one? You are given spherical coordinates, which is theta and phi. Whenever you are given theta and phi, these are spherical coordinates. So whenever it's theta and phi, these are spherical coordinates. So from spherical, you must reduce it to Cartesian coordinates. So these are the Cartesian coordinates, which we find in 3 dimensions, x, y, z, Cartesian coordinates. Then the next question, you also have to put it in what? In Cartesian coordinate. But don't forget that identity. Don't forget the identity, which I told you. So which means you need, yes, the identity of the Euler identity. This one. Very important. The Euler identity is also very important. So which says sine theta e to the power positive or negative I phi is equals to x over x plus or minus I y over r. In other words, what does that mean? It means if I use a positive, it corresponds also to a positive. For example, sine theta e the power I phi is equals to x, then it also corresponds to a positive. Why? Because there the sign is also positive. Over what? Over r. So that's what it means. So by doing it twice, it means you must know whether are they subtracting, and there's a complex number I in front of the y always. I y, which means the complex number. We are working in complex there. So let's go for it, for which means number 2. So we are going to be using that. So for number 2, we are given that, and this expression was given in the question, that y3 plus or minus 1 of theta and phi is given by this. So in terms of Cartesian coordinates, that is what we want to put in terms of Cartesian coordinates. So which identity which we are going to use? This identity which I was explaining to you. Right. Then cos squared theta. What is cos squared theta? We are using it from the definition of cos theta. So where there is cos squared, why are we saying cos squared? Because we want to substitute this. Can you see this? Cos squared. So I must find a trig ratio that replaces cos squared into x and y and z, Cartesian coordinates. So cos squared z squared over r squared. So it's sorted. All right. So cos squared, I have sorted it. Then you need also for sine. So let's check for sine. We said sine theta, this one, sine theta is being multiplied by e. So the trick that they moved the e to the outside, but yourself, you must know that the e, you can rewrite it next to the sign if you want. For example, you can simply say this can also be sine theta, and then it's e to the power positive or negative I phi. Then you can multiply again by 5 cos squared, cos squared theta, cos squared theta minus 1, close your bracket. So you can rearrange multiplication. Remember, multiplication is commutative. You can reverse the order. So that is what happens. So they use this identity, which is x plus or minus iy. That's why here, now we are having this x plus or minus. And the replacement of the cos squared theta minus 1. Cos squared theta, z squared over r squared multiplied by 5 minus 1. So this was our cos squared theta. Is sitting here. Then the remaining sine and e, it decomposed to this. This was our coefficient, nothing changed. So everything now is in terms of x and y. We are just rewriting. We don't want r. R, it must be removed. So r, r must go. But we know what is r squared. R squared, just replace x squared plus y squared plus z squared. That is our r squared. So you replace everything where there's r squared, x squared plus y squared plus z squared. Then if you want to simplify, what is 5z squared minus r squared? Then in terms of Cartesian coordinates, you can simplify it. Because 5z squared minus z squared, then it becomes 4z squared. That is what is happening. So now everything is in terms of x, y, and z. So this is what we're just basically doing. These are just giveaway marks. Nothing is difficult. Just a matter of substituting and seeing and knowing the Euler identity. Any question?
So far, no.
Right. So I will share the questions, the solutions. Then the next time we meet, we'll do the assignment, and then this one will continue. We are left with 4, 5, 6. So 4, 5, 6, 7. So there's still a lot of questions for 2025. But I guess while we are doing assignment, we are covering some of the questions here.
Yeah, because it's the same.
All right, let's stop here for today. I will share the recordings.
Oh, and the notes as well. Yeah. Okay.